Assalamualaikum warahmatullahi wabarakatuh. This presentation is entitled 3 Men and 2 Theorems, which presented by me, Siti AQILAH binti Muhammad AZHAR as the first presenter, Mardiana binti Muhammad SHAH as the second presenter, NAZIHATUL AMIRAH binti Muhammad FADZIL as the third presenter, and ASIKIN binti JOHARI as the fourth presenter. Recall on line integral. Line integral is an integral over a curve C. It is just a single integral which is not an integrating over an interval a to b. When there is existence of a vector field f equal to pi plus qj, therefore the line integral over curve C of f dot dr is equal to integral along the curve C p dx plus q dy. Since the vector field is on two dimensions, the double integral of curve f over the region D enclosed by C is equal to dq over dx minus dp over dy. There is a theorem that can be used for closed curve C with area of D, which is Green theorem. Green theorem is a relation between the line integrals of a simple closed curve C and double integral over the plane region D that is bounded by C. Since both right-hand side of the line integral equation and double integral equation remain the same, the Green theorem is integral along the curve C p dx plus q dy is equal to double integral over a domain of dq over dx minus dp over dy dx dy. The conditions applicable for Green theorem to be applied are when the C be a simple closed curve in the xy plane, positively oriented where it is moved in counterclockwise direction and piecewise smooth. Other than these conditions, except for the direction of curves, is not applicable to apply this theorem. Green theorem is a convenient way to be used in calculating closed curves since line integrals is more complex to calculate the ordinal integrals. As seen in the figure, it is also can be applicable for negative orientation. If the curve is negatively oriented, which means the curve moves in a clockwise, the curve still can be applied in Green theorem, but the sign will change at the right hand side of the Green theorem, as shown in the slide. Regarding on Green's theorem, it related with double integral over domain D and line integral of simple enclosed curve C that lie on xy plane. When the enclosed curve C is in 3 dimensions, Green's theorem is not suitable to be used. Therefore, Stokes' theorem can be applicable for higher dimensional version of Green's theorem. Stokes' theorem is a relation between the line integral of enclosed curve C around the boundary as in 3 dimensions and the surface integral of curl f and the surface integral of curl f dot n around the surface S. Since the tangential component f of line integrals around the boundary S is equivalent to the surface integral over curl f dot n, therefore the Stokes theorem is integral along the curve C f dot dr equal to double integral over the surface S of curl f dot ds. When it expanded, it is similar with double integral over surface S of curl f dot rx cross ry dx dy. The conditions of Stokes' theorem to be applicable is same as Green's theorem, which the surface that bounded by the curve C must be simple, closed, piecewise smooth, and positively oriented. To identify the direction or the orientation of curve C in Stokes' theorem, an analogy of hand side can be used. The figure shows someone is walking around C with the head is pointing in the n direction. Thus, if the surface S is at the person's left hand side, then the boundary curve is positive orientation. Otherwise, if the surface S is at person's right hand side, the boundary curve C is negative orientation. Now, I shall hand over this presentation to Mardiana.
The similarities and relationship between Green's theorem and Stokes' theorem. Green's theorem in the plane is a specialized version of Stokes' theorem. Green's theorem states this for a two-dimensional object residing in two-dimensional space, while Stokes' theorem states this for a two-dimensional object living in three-dimensional space. Statement of Stokes' theorem to the statement of Green's theorem are very similar. Stokes' theorem is thus a generalization of Green's theorem from circulation. It indicates relationship between line integral in plane and a double integral in space. So, the curl of Stokes' theorem that are similar to the curl form of Green's theorem as follows.
Hi, my name is NAZIHATUL AMIRAH binti FADZIL, and I will introduce the mathematicians and physicists that discovered this method. The first one is George Green. He is a British mathematical physicist. In 1801, he studied at Robert Goodacre in Nottingham and left the school in 1802. After that, he thoroughly studied on his own. In 1823, Green joined the Nottingham Subscription Library and had access to a few scientific works. In 1828, he published his first work on the application of mathematical analysis to electricity and magnetism theories. After that, he wrote papers on electricity and 3 papers on hydrodynamics until the year of 1839. So we can see that George Green is a mathematician that recognized for Green's theorem and Green's potential theory. Next, we have William Thomson, which also known as Lord Kelvin. He is a British mathematical physicist and engineer. In 1834, he studied at Glasgow University in United Kingdom. In 1838, he began his university-level work, and in 1841, he entered Cambridge University and published his first paper about Fourier. William Thomson has published more than 600 papers with physics and engineering direction. Third, we have Augustin Louis Cauchy. He is a French mathematician, engineer, and physicist. In 1802, he enrolled in a central school, and after graduate, he started his study at an engineering school. Cauchy wrote his first paper in 1811, and since then, he produced more than 700 mathematics papers over 30 years. Next, we have George Gabriel Stokes. He is an Anglo-Irish physicist and mathematician. In 1832, he studied at Reeve R.H. Walsh School. He also used to attend in Bristol College and Pembroke College of Cambridge University. His first paper was published in 1842. His paper was mostly about fluid and light. Stokes settled the science of hydrodynamics with his popular theorem, namely as Stokes' theorem. The last one is Hermann Henkel. He is a German mathematician. He began his education in Nicolai Gymnasium in Leipzig, and in 1857, he studied at Leipzig University in Germany. Hermann Henkel was a mathematician who worked on mathematical history, the functions theory, and complex numbers theory. He is recognized for the Henkel matrix and Henkel transform. Roles of Green, Thomson, and Stokes in discovering the theorem. It was tied with George Green, who proposed the theorem. In 1828, he published his own work, which titled as An Essay of the Application of Mathematical Analysis to the Theories of Electricity and Magnetism. Once the essay was published, it was not well known, and only 100 copies were printed. In 1840, he died and leaving behind his essays. In 1845, William Thomson unintentionally found a photocopy of Green's essay and realized the essential aspect of Green's theory. William Thomson, which also known as Lord Kelvin, made further advance in mathematics and science using Green's essay. After that, Thomson became a professor at Cambridge University and worked alongside a man called George Stokes. Both of Thomson and Stokes have interest in Green's theory. William Thomson then continued in physics and chemistry, with making significant advance in the theory of heat, electricity, and magnetism. George Stokes also explored Green's theory and wanting to present the theory as a question in Cambridge examination. Because of his habit of taking the theorem as an issue in the exam, the theorem then was called Stokes' theorem.
The discovery of Green's theorem and Stokes' theorem. From the study, both theorems have been used in solving problems of electricity and magnetism. In 1828, George Green, who is an English scientist, was publishing an essay on the application of mathematical analysis to the theories of electricity and magnetism. It says the documented theorem equivalent to the Green theorem. Next is the Coke theorem, or known as Stokes' theorem. It is applied in the subject of electricity and magnetism. The theorem was found in Maxwell Faraday law and Ampere's law. It is used to transition between differential form and the integral form of the equation. There are some examples on how both theorems are used in solving the physical problem. For the Green theorem, it can be viewed as integral identities. The theorem can be used to obtain the conservation of energy, the uniqueness, and reciprocity in three-dimensional and two-dimensional problems. The uniqueness theorem, which is a time harmonic electromagnetic field from the Green theorem, can be derived. The first assumption is the delta epsilon equal to 0. This is because the first term on the left is equal to the right hand side. The result provides more insight than the usual proof of the uniqueness theorem. The differences field must be homogeneous solutions, so later on it will be equal to 0. Hence, both solutions satisfy Maxwell's equation. For the Stokes theorem, there are some experiments resulted in electromotive force, were expressed by the flux rules and in the fact of the changing magnetic field induces an electric field. From the equation here, it can be related to the change in B by replacing the change in flux with respect to time. The equation is known as a Faraday law in integral form. The Stokes theorem can be used for the differential form. It is applied on the left-hand side of the equation. The equation carries a sign ambiguity due to assumptions that the right-hand rule is used to find the direction of the motion. It can be differentiated with respect to time, as the integration of the surface does not vary with time. From the equation here, B is a function of the coordinate system. The partial derivative must be used. Hence, thus, the vector integral must be equal, as it assumes that the Faraday law is true for every surface. Therefore, it obtains the Maxwell-Faraday equation in the differential form.